All right, very good. All right, thanks again, everyone, for joining. Let me know if you have any problems or anything. Thanks for interacting already, letting me know if things are working or not. My name is Jason Turner. If you don't know who I am, I have been publishing YouTube videos on C++ weekly since March of 2016, 520 weeks straight now, and you can subscribe to my YouTube channel if you want. I'm also an author. I've got some best practices books, a lot of puzzle books that I've been working on, and you can check out those things if you'd like to as well. I am a developer and a Microsoft MVP, and I do have a bunch of GitHub repositories, possibly too many GitHub repositories, if that's a thing. I don't know if that's a thing or not, but I have a lot of GitHub repositories up there. So I do training. That is the main thing that I do today. You can go to my website and check out more information about that. I love doing on-site training. I love interacting with everyone. I have been to lots of countries, and I would be happy to come to your country. And you know what? If you want me to do on-site training at a country that I haven't been to yet, there's a chance I'll give you a discount just for that. Conference workshops. Obviously, I'm giving a preview for this workshop that's coming up for C++ Online, but I will be giving a similar workshop at C++ on C in Folkestone in June, and NDC Toronto coming up in May, and CVPCon, NDC Tech Town. So I'm going to be doing lots of conferences this year. There's a QR code and URL if you just want more information on that stuff. Yes, the actual workshop is April 9th. Go sign up right now. Go do it right now. Sign up for it. Okay, I'll keep moving. This is real material from other classes that I teach, but I have extracted something that will not be specifically in the workshop that we will be doing on April 9th. The style is going to be the same with interaction and, confusion about what things are on which monitor. We're going to see how far we can get in 1 hour here. Well, this will be really interesting. We'll see how this goes. This is the actual, this is where we're starting right here. We're jumping right into it. Let's review this function. This is a 3-line function. And I have spent an hour with classes on this 3-line function, just so you know. So go ahead, if you want to jump in, I'm going to go ahead and pull this up in Compiler Explorer so we can edit it live. If anyone has anything to say, go ahead, just give me a thing that you think, well, first of all, I want to say this, this is not completely fabricated code, right? If you've got an application that, say, has a CLI, there's a very good chance that you have some hard-coded string like this, right? And you're going to say, return the product name so that you can print it out. This is not completely fabricated. This is not really just slideware, and it gives us a lot to talk about. So yeah, we'll see how this works. I haven't given an online workshop in a really long time, but if you've got something to say, just either chat it or unmute yourself and just one thing only, and we'll see how many things we hit.
Is it possible that it's returning a reference to a temporary?
Is it possible it's returning no, it is not actually returning a reference. I kind of intentionally confused you in how the code is formatted here. It is not returning a reference, it is returning a value.
You have the const before the type, which is useless, I would say, because you're returning by value.
So that is an interesting one. Is it useless? Let's go ahead and do a quick, no. I'm going to do this. Now, I'm making the situation worse, but let's do that. What have I actually done on line 10? Does anyone tell me what function is actually being called here? What operation is happening on line 10?
What the copy constructor?
It is the copy constructor. Why is it the copy constructor?
Either the copy constructor or the copy assignment operator. So
Oh, sorry, not copy. Yes, you're right. The second time, copy assignment operator. Yes, copy assignment operator is happening, is being called. So why is it the copy assignment operator? That's the question.
because you have a variable already and you're just assigning the value that you got from the function return into this variable, so it's not a move. Like
It could be a move, but I've done something that's damaged the ability for it to be. Who said that? Kevin, is that you?
Const.
Yeah, const.
Yeah.
So the fact that I made this a const value actually. I'm sorry, say that again, William? Or oh, okay. The fact that I made this a const value actually did change the meaning of the code. This is currently a copy assignment operator. And if we're lucky, we can disable optimizations and we can actually observe that. If we don't have optimizations on, it's much harder, but we can see hopefully somewhere. There we go. There's the assignment operator, and I can see it as the assignment operator that takes a const reference. So if I remove const here, then I'm actually going to get the move assignment that I want, because this is a temporary, it is implicitly an R value, and then I can match to the move assignment operator. That is going to be a fair bit about what my keynote is about tomorrow. So for those of you who are watching on YouTube right now, I think that you should just go ahead and sign up for C++ Online. It's like super affordable, and you can come to the keynote tomorrow. Okay, let's play with this real quick and see if I did this instead. So I went back to this const value returned from get product name. Now going back to line 10, what operation is happening here?
since this is const again, so I don't think you can pass it to the move constructor. So this
It's
is
true that you could not pass it to the move constructor, but the thing about this particular operation is that this is going to be neither a copy nor a move. I am surprising to almost everyone is if I were to do this, I change the generated code. Not at all. Let's see. I'm even in a debug build. Let's see. That's like do a quick double check here. Yeah. Just by a quick, output line count. I'm not changing the meaning of the code at all. And this really surprises most people.
return value optimization.
I don't like calling this return value optimization because the compiler has to set up a place on the stack for that return value, no matter what. So in one case, I am giving that location on the stack a name. And in the other case, I'm simply not giving that location on the stack a name. So I've given the thing a name here, and I've not given it a name here. But either way, the compiler had to set up a location on the stack, had to pass a pointer to that location on the stack to the get product name function, where it began the lifetime of this return value of the string. So const here doesn't actually affect the code generated in this particular case, where I am assigning it what looks like assignment, but is not assignment. It is object initialization, and it is the equivalent of doing this. I'm not affecting the generation of this code at all. That doesn't mean this is good. This is bad. You already all called it out. This const value return, const return value, the fact that it's not a reference, this can break move assignment. So we don't want that. And let's just go ahead and remove that const. And we'll still leave the example down here because this will make things interesting again in a moment. Okay, any other single comment about our code at the moment. Just looking for one comment at a time. Normally I would have groups like break up and I'd have you all discuss things with each other and then I'd bring you all back together and I could theoretically do that here, but that's not going to work well for the streaming on YouTube anyhow.
You should probably return a string view instead.
I should
We-
probably return a string view. Who said that?
It's me. Hi.
Oh, hi, Philip. Sorry. I'm looking, it's by the time I look over at the screen and my eyes like focus on it, the little like green rectangle saying who was last talking is gone. So, all right. So I should probably return a string view. Wait, does this make anyone nervous?
Yes.
I'm not surprised that it makes you nervous because we know that a string view, well, many of us know. So a string view is what? It's basically 2 pointers. I don't know. It can be implemented in 2 different ways. So it is like a begin pointer and an end pointer, effectively, right? It can be a begin and a size, but that is from our view, like literally the exact same thing. It's a question of what are you optimizing for? Are you optimizing for the begin and end operations, or are you optimizing for the length operation? So one of them is going to have a simple add of the pointer, and the other one's going to have like a subtraction of the pointer to get to the end, right? So it's effectively 2 pointers. It's a 2 words thing. Okay, so what is this a pointer to? I'm returning a string view. What am I returning a pointer to?
We have
It's a static global data.
It is that is true. So let's see. Let's do this here. A character string literal is guaranteed for the lifetime of the program. So it is basically a static object. It is a static object that is constant initialized. Constant initialization is its own rabbit hole in the standard if you haven't spent any time looking at that. I've addressed it in a few of my YouTube videos. But basically we can observe it right here somewhere. Hello. Oh, there it is. Look, it's at the top of the binary today. Depends on the compiler. So my awesome product is a string. This lives for the lifetime of the program. This is all right. I'm returning a pointer to static data. Okay. Any other?
with you.
Sorry, that? Oh,
Fine.
Oh, I mean, that's fine. I'm just listening to Jason do it.
Kevin, you're live on the internet. All right. Uh, all right. So any other comment now that we could talk about for this get product name function?
In this specific case, this is fine to return a string view, but like it's not okay if this string was allocated on the stack because you'd be basically.
Oh yeah, there's several ways that we can make this bad for sure. So I could do something like I could do this and then I return name. This is really not good. Oh, and look, no warnings from my compiler at all. Thanks, GCC. This is not good because I have explicitly said create a local sized by the compiler array, and then I'm returning pointers into that local sized by the compiler array. And I don't even like the actual string data of my awesome product, it went away. Like it's here. This is fun. it's here. This is my awesome product. This is it being copied onto the stack right now by the compiler. Let's turn on some optimizations because GCC is funny about this kind of thing. Oh, here we go. When I turn on optimizations, GCC is now able to say, let's see, using a dangling pointer to name. So this is something that GCC is able to pick up on the back end. We can see if Clang has a similar warning today. I've got Clang 20 installed. Let's see, warning of address of stack memory associated with local variable name. And what we can observe as well is that Clang does not tend to be dependent on optimization level for this type of warning. So that's cool. We can get a warning from Clang. That's good. But GCC, I had to do an optimized build. Let's try something else. Let's do a product name. And let's turn on execution. It's funny because I bet Clang is going to print the right answer here because it's just my guess. Oh, it didn't. It's my awesome ? W backslash. That's it's almost the right answer. And GCC. What's GCC gonna do? GCC is just a bunch of question marks, and then we can see how optimization plays into these things or not. This is a fun one. Accessing an object after its lifetime has ended. I think I can find a scenario real quick. Maybe not. There we go. Clang with optimizations enabled printed the correct answer. Go undefined behavior. Like we just have no idea what's going to happen here. This is great. Okay. How would I actually catch this? Let's say I'm back in GCC and I've got optimizations disabled. Therefore, I'm getting no warnings from my compiler. Is there anything I can do to catch this bug?
Use sanitizers.
I can use sanitizers. That's
You build
it.
memory.
Yeah, do I want to use address or undefined or both? Which one is actually going to catch it? I believe address sanitizer is the one that catches this particular error. Let's hope it catches it. Error, address sanitizer, stack use after return on address. All right, that's awesome. And if any of you watched my recent YouTube video on undefined behavior, we might see a scenario here where Clang no longer gives us an address sanitizer error because it optimized out the undefined behavior, which is super crazy. All right, no, we don't get that in this case. All right. So that's bad, and I appreciate that's bad. We do have some tools that can help us catch it, but let's get back to just return my awesome product. All right. And now our comments are correct again, fortunately. Okay, so we have to be careful. Through some lens, we have to make sure that our tests run on sanitizers. All right, let's take another, okay, make another comment about this, anything that you would change or add or remove or whatever.
What happens if we try to modify these characters via the string view? Is it allowed since it's static data?
String view only has const accessors, so you would already have to be in the realm of undefined behavior, like const cast away a pointer return from the string view or something like that. And I would really, really strongly recommend against doing that personally. So there's no direct way to do this. We would have to go out of our way to do it. Let's see. I am wearing one of my new t-shirts. I don't know how visible this is on the tiny thumbnail of me. Yeah, anyone? Constexpar. It's the pirate of Constexpar. He's my favorite character in the C++ universe. So is there anything else that you would change about this function?
Consteval.
Ah, hey, wait a minute. Consteval, you're skipping ahead. But let's all right. I'm gonna change around a couple of things. You said consteval. I will acknowledge that. And I'm going to go back to this version. Now, an interesting aspect of consteval forces to compile time the evaluation of this function. This function must be evaluated at compile time. Now, notice I get a compile error. Error, called a consteval function, get product name is not a constant expression. Subobject name is not a constant expression. I'm not allowed to return a pointer to this thing at compile time. The compiler will simply forbid me from doing this. If I made this constexpr, I can still get myself back in the realm of undefined behavior because this get product name at the moment is not being called at compile time. It's not being evaluated at compile time. Constexpr function is a function that may be evaluated at compile time. Consteval must be evaluated at compile time. So this still lets me get that undefined behavior. But if I make this thing consteval, as you suggested, then this becomes impossible. And now I know, for anyone who was concerned about the fact that this thing is returning a string view, you simply, you can't be concerned about it anymore. Or some, version of can't, because this thing must be evaluated at compile time. Undefined behavior is not allowed at compile time. Therefore, this function doesn't have undefined behavior. Does that string of logic make sense? So it's effectively impossible for a consteval function to have undefined behavior or return an object itself that, points to an invalid object, basically. All right, so my awesome product. Okay.
I've got a short question.
Mhm.
The consteval, doesn't it force it to be evaluated at compile time? So, for example, could you still have another shift operator behind the function call?
Another shift operator behind the function call?
Yeah, because so 924, after calling get product name,
Yes.
if you would just append another string, for example,
Oh.
this still work with consteval?
Yeah. So what you'll get in this particular case, I didn't know, like for some reason, shift operator, yes. That's
technically appending a string, but
yeah, it's actually going to be two completely separate operations, right? This, let's see, how do I take a step back here? Let's do that. And then I'm actually going to jump into the disassembly and I'm going to hope that I can give you like a direct answer. Yeah, here we go. No, that's not what I wanted. Sorry. It's having to create this data at compile time. And the entire function call and the object have been removed. So it's getting a pointer to that .str, and then it is, and then it's passing 16. And what we can actually see here is like this RSI, RDI, RSI pair, these two parameters that are the first two parameters to a function with our Itanium ABI here. It's basically the first pointer is the first value to the function is a pointer to that string. The second value to that function is the length of that string. So it's forcing that thing to happen at compile time. And then I see this, those are the two parameters that are being passed to the, here we go, OStream insert operator. So if I were to then append a second thing here, that first part is going to stay exactly the same. And then we should just see a second operation after that that is setting up the call to print hello world. Yeah. So we see that string with a length of 16, and then we see a separate insertion operator or left shift operator that is string.1 with a length of 11, and that's our hello world string coming in down here. Right. So yeah, that doesn't really change anything. In both cases, the compiler is just going to set these things up at compile time in a release build, and in a debug build, it will still set up the my awesome product insertion at compile time, but not necessarily the hello world insertion. But if I did something like this, oh well, if I do that, I'm not getting at all what I wanted probably. But if I do this, this is going to fail to compile because this is a string view and a constant character literal, and there's no plus operator overload for those two things together. So hopefully that made sense. My answer there.
Yeah, thank you.
All right. You're welcome.
Just a question, like when we are using consteval here, we're just basically abusing consteval because like it's not doing anything aside from the original implementation.
It is doing something. In the case of a debug build, this object, this string view object itself, will be set up at compile time. And in the case of, say, constexpert here, I'm going to make that constexpert, or well, I need to get it compiling again. Sorry. Get rid of that. Get rid of that. And I'll leave the constexpert there. And I'm going to turn off optimizations. And then I will scroll to this line as soon as the compile is done. Reveal linked code. And string view, constructor, const character pointer. Yeah. I'm not finding what I expected to find. One moment. I'm going to change compilers. We can often actually see where if that thing is not consteval and it is in a debug build, then you'll actually get a call to strlane emitted because it has just a pointer to a character array, and then it has to actually like count the number of characters in that thing. And I do not see a call to strlane being generated, but compilers constantly surprise me when they get updated. I'm going to get rid of all of the UB SAN instrumentation as well, so this is slightly more readable. Yeah. All right. Yeah. It's not doing that. Let's make it const. Oh, GCC. Right. GCC will often choose to evaluate constexpert functions even in debug builds, so that's also messing with me at the moment. I think that's what's happening here. Yeah, GCC is actually like hard coding in the length of the string and everything, even though it's a debug build. These things, it's kind of funny having done this for several years now. When I talk about this kind of thing, and I'll stand here with a lot of confidence and tell my students, well, we can see exactly what the compiler is going to do in this situation. And I happen to have just updated my compiler, and now it does something different than it's done for the last 10 years. And I'm like, oh no. But I mean, like, good, our compiler's getting better, but you know.
Well, as far as As far as my experience with GCC and MSVC usually doesn't tend to do these optimizations automatically. So maybe
I have seen in many cases where GCC will evaluate a const expr function, even a debug build, effectively making const expr functions so they cannot be debugged by in GCC. I've seen a few cases of that. That's been, I cannot remember the specific details, but it was an example that I called out in a talk I gave last year called consteval all the things, where GCC was just evaluating stuff when I didn't even want it to. But either way, I don't think this is an abuse of consteval. I think this is an actual correct use of consteval. I have a function that takes 0 parameters. I never want it to be evaluated at compile time because all this thing is doing is returning a string view. And I want to ensure that the thing does not have undefined behavior in it. To me, this is a perfect use case for consteval.
does this function does this change the signature of the function if this is an exported function or something?
You cannot export as a consteval function. It doesn't really have a signature. It doesn't exist.
Okay.
Consteval functions will never, well, assuming no bugs in your compiler, a consteval function will never be emitted into the binary. You'll never see a signature for it. So we're in this, oh yeah, that's a good point. We're in a debug build. This function is consteval. We see no call to it here. And this, I think, will actually prove my point. Now, no, it is calling get product name. Okay, and const expr here. All right. Yeah. So there we go. That's part of the point that I wanted to make. So by making it consteval, the compiler is never ever supposed to emit that function into the binary. Yeah, there we go. That's doing what I wanted it to do. Okay. Anything else that we would comment on about this function? Oh, I'm going to finish this note here while you all think about it. So this, I think, goes exactly to the point of the workshop that will be coming up on April 9th. Is here we've just constructed a function. Now, granted, this is a very simple function, but we did already show how it's possible for this function to have both runtime cost and undefined behavior. And if it's something that I can force to compile time, this is something that cannot have runtime cost or undefined behavior. And I think the point of my workshop is performance and safety. So I think those two things apply here. All right. Anything else? Anything else? I have several more things I want to talk about. Give you all a second. All right. I'm going to do this. Does my code have a bug in it right now? Do we think it has a bug? I think it has a bug. Interestingly, warning expression result unused. Clang, you're kind of jumping ahead of me here. I will. It's also just interesting to play back and forth with compilers and what kinds of warnings you get from them or not. So GCC is not giving me any kind of warning here, and I feel like this is probably code that should generate a warning. I am calling a function and I am ignoring its return value. So I would make this function no discard. And now I get a warning because clearly I should not just be dropping the return value from this function. There's a few other things still to discuss. Anything else that anyone would like to comment on this function?
You
There's a
forgot
D
the
missing
D-
listed.
Excuse me? Oh, no discard. No discard. So I was just going with the pirate theme. No discard. I should do a new t-shirt. It's okay. No discard. That is what I was going for. Thank you very much. If I had a prize, I would throw one at you right now, but I do not have one that I can do that with virtually. All right. Is this a function that could ever throw an exception?
Well, it's consteval, so it can't, right?
Oh no, consteval functions as of C++ 26 will be able to throw exceptions. They just must be caught during constant evaluation. We have const expert exceptions coming thanks to Hannah in C++ 26. But this thing, we know that the constructors for string view are no except. So this can be no except. Then I just have a question to ask. Like, okay, we have sprinkled all of the decorations on this thing. I don't think there's anything else left for us to talk about here. But are you a fan of trailing return types? Anyone? I don't know. Raise your hand if you are. No, how does that work? I don't know. Give me a thumbs up if you are a fan of trailing return types. No one is a fan of trailing return types. Not a single person in.
What
I'm
is
neutral.
What is trailing return types?
Okay, what are trailing return types? That's a good question. That is where I can format this like this. Oh, hello. That is
Oh,
the wrong thing to have pasted there. That was
this is horrible.
It's horrible. Who said it's horrible?
Me, I just I'm the one
Mustafa?
who asked about what is trailing return types. I just
So
know
this
that
is
by-
this is trailing return types. You put auto as a placeholder here, and then you specify the return type at the end of the function declaration.
I know how they look. I just don't know their names. I don't want to touch these things.
You can touch them. Okay, so this is not meant to be the point of this thing at all, of this particular session, but when students go in a direction, I feel like morally obligated to follow down that direction, right? And see what you care about and why and what your concerns are. So if I were to say write some sort of lambda, like this. This is a lambda, it just returns 42. That is a lambda. No, come on, not home. Equals. There we go. I'll do that real quick. If I want the return type of this thing to be a uint16, how would I go about that?
You can just cast the number before you return it.
I could. Something like, oh, you know what? I've really got to turn off the autocomplete on my braces. I can do that. What is the other legal possible way of specifying the return type of a lambda?
Trailing return types.
Trailing return types. So just out of curiosity, who of you also programs in Python? Come on, it's everyone, right? I know, yeah, you don't even have to thumbs up. It's all of you. You all also program in Python. Who uses type declaration, type decorations in Python? Like, yeah, use the type decorations. If you're going to specify the type of a function in Python, where do you put it? Goes at the end, right? Goes at the end. All right. Is anyone else program in Rust? No. No one here programs in Rust. You wouldn't be at a C++ conference if you did. But if you happen to program in Rust, do you know where they put the return types? At the end. Like, I know some of you program in TypeScript. I'm sure of it because I do this with students all the time. And if you're going to have a type declaration for a function in TypeScript, where does it go? It goes at the end. All I'm saying is that it is consistent within C++ and it is consistent outside of C++. You can do whatever you want to do, but this, I think, is the argument for using trailing return types. All right, let's get rid of that. I just want you to think about it next time you write code. No, don't do that. Don't randomly use trailing return types in your project that does not currently use trailing return types. Have a consistent plan that everyone on your team agrees to. Just understand the arguments for and against. All right, so this is crazy. This is a lot happening here. Does anyone have any other ideas for how I might do this? Seems like a lot. Comments? No? Anyone? Matthew?
Just a question. Is this all this function does? Just return?
It is all this function. It's all it does. All it does. Yep.
Then why not just create a string? Constant string or constant string view.
Const expr product name. Maybe. Oh, no, I know what I'm going to do. Const expr auto product name equals. Just for the sake of consistency. I really don't need the function, right? This is just a compile time constant, really. So that's perfectly fine too. And this is also just an aside that if you really want to go with the type is on the right-hand side of the thing, you can own it all the way, almost all the way. There's one place where we're not allowed to use auto and we can't have the type of the thing on the right-hand side. Does anyone know where it is? Super frustrating.
Main function?
No, you can with main, actually.
Initializer list.
An initializer list. Well, I guess function parameters in general, you can't really specify the type on the right-hand side. That's fair. So there's two places that I'm thinking of. This is the one that frustrates me. Let's see, auto value. If I wanted to specify a default value for a member, so like member initialization like this, I'm just simply not allowed to do that. I have to specify the type here. I'm not allowed to use auto type deduction, which is like super weird. There we go. That did compile. It's making me nervous. Compiler Explorer taking a little second there on the back end. All right. This is my own local Compiler Explorer instance running too, just so you know. That's really easy to set up. Okay, so this is something. This is a value that is initialized to the thing that I care about. It's impossible for this thing to have undefined behavior. It is initialized at compile time. There's one subtle tweak I would make to this particular declaration if I was going to keep it here. I would make this inline, which counterintuitively, I feel like we intuit that inline means everyone gets their own inlined copy, and that's not accurate. Making this inline means that if this is in a header file, and it is that header file is included in multiple object files, then when those object files get linked together, all of the implementations of product name will get merged into one. If it's static, which it's implicitly static if I don't have the inline here, then each translation unit will have its own copy of this data. And in this case, there will be one copy of the data across the entire executable object once it's linked together. Very counterintuitive, but that is what it does. I've proved it to myself multiple times because I always find it confusing. Okay, we are definitely don't have enough time to start another topic. So we have to do one more. Let's clean up the comment a little bit. Let's get rid of this. We need to, those things are still true. Force evaluation compile time, which makes it impossible for this function in this particular case. Now this comment is still correct, but I'm talking about the constructor for string view. So I know that this thing's going to be forced to compile time. All of the, what's the word I'm looking for? Yes, all of the instances of product name into one location. All right. I would not recommend actually putting this many comments in your code because hopefully the reader of your code knows the stuff. All right. I have the entire example fit on one slide now. Let's do one last code review and then we'll wrap this up. Does anyone have anything to add here?
Is it
Missing
possible
return of
to
the
make
main
it?
function.
Oh, wait a minute. I heard two different things at once. Return of the main function is an interesting one because in C++ it is well defined that if main does not return a value, it implicitly returns what?
0, I guess.
0, I guess, is mostly accurate. I believe it's technically defined as returning exit success. It's defined as returning whatever is the success code on your platform. It just so happens that every platform uses 0 as the success code. So it depends on how pedantic you want to be there. So you know what? I'm okay either way with this or not. What was the other comment?
Why don't we make it consteval so that the constructor of the string view gets evaluated at compile time?
Consteval applies to functions to say that the function must be evaluated at compile time. A constexpr object is going to be, the data for that constexpr object will be evaluated at compile time. That's guaranteed. And we, where did that comment go? By doing constexpr, so there's a really esoteric rule here, a static object initialized with a constant expression is constant initialized. This is like a rabbit hole that we don't have time for this exact moment, but this thing called product name is static in the sense that that is its object lifetime. Its lifetime is for the lifetime of the program. And so therefore I know whether or not constexpr is here. This thing will be initialized at compile time. It's required to be because the constructor for string view itself is constexpr, and I am passing the string view a constant expression. But by putting constexpr here, I know for a fact this thing is going to be initialized at compile time. It has to be. And as someone who's super pedantic would argue with me that technically, according to the rules of the abstract machine, it could actually be initialized before any user code is executed. But practically speaking, this thing is initialized at compile time. We can't do much better here, or any better that I know of. All right, anything else? I have one other thing that I want to say if no one else sees it.
Do we want to use print instead of cout?
Did you watch my last video? Are you just making fun of me right now?
I know. I just saw the title. I haven't watched it yet.
We can use print. Yes, sure. Let's use print. That's fine. It's print is great. Print is fine. Use print. Okay. When you do go watch that video, be aware that it has the subtitle of "in these videos," right? It doesn't say I never use print. It says I don't use print in these videos because it takes flipping forever to compile inside of Compiler Explorer, and then it generates a giant mess of code that makes it impossible for us to look at the binary. That's really the takeaway here. So cout, it's just like simpler when I'm doing like live coding because we can easily read the binary and we can reason about what the code's doing more. But yes, print is great. Print is great for production code. Anything else? Come on, still got one thing. Super subtle.
Wrong header for string.
I no longer need string. I'm only using string view instead of string. You definitely deserve a prize. I'm sorry I don't have one to give you because it's been several good answers.
Speaking of
Yes.
headers, CSTD def is missing for the exit success return value.
That is, yes. And as it's funny as you say that, because as I typed it, I'm thinking in my head, I'm almost positive this is going to compile because I'm already including IOStream and it's probably transitively included. But if you're doing any sort of header include, sanitization, whatever of any sort, then you probably would have gotten a warning on there. CSTD def, missing a D. And honestly, I wouldn't have been able to tell you off the top of my head where that was. Did you look it up or do you know it off the top of your head?
Oh, maybe it's an std lib.
I'm sure it's somewhere. All right. I think we did a good job just completely tearing apart a 3-line function in approximately an hour. This is if you've never had the opportunity to do this, I do suggest that you take some project, like your own favorite toy project or some function at work, if you can get the approval to do this, and just like, I am going to perfect this class. I'm going to perfect this function. I'm going to see how far I can go. I'm going to analyze every line of it, and I'm going to see then what does that mean for, like, you know, you start at the first line, you work your way down. And it is just an awesome experience when you are finally like, you know what, I'm done. I don't think there's anything else that we can add to or take away from this. There's still an argument for making product name a function, by the way, depending on how that actual product name string gets filled in, because you might be using internationalization or compiling different like objects depending on, you know, different sub products of your main product line or whatever, right? So there's different arguments for that. But if you don't need the function, you can do this. If you do need the function, try to make it consteval. If you can't make it consteval, make the thing constexpr. Make sure you know what you're doing with those string views, and so you don't get yourself in trouble that way. But otherwise, I think I'm going to wrap it up here. If you have any questions, go ahead and ask them, or we can move the questions to gather town.